Welcome. Up till now we have seen basic mechanical elements, basic electrical elements. Then we have seen series and parallel electrical law or series and parallel electric circuit. Afterwards we have seen problems on series and parallel electric circuit. Then we have seen series and parallel mechanical elements. Then we have seen grounded chair representation. Then we have seen problems on grounded chair representation. Now today we will see analogies. Analogies means similarities. Therefore, we will see the similarities between mechanical circuit and electrical circuit. That is similarity between mechanical element and electrical element. Therefore, we have seen this RLC series circuit in which current I is flowing through the inductor, resistance and capacitor. EL is the voltage drop across inductor. ER is the voltage drop across resistor. EC is the voltage drop across capacitor. Therefore, total voltage drop E is equal to EL plus ER plus EC that we have seen. Therefore, this is known as series electrical system. Afterwards, we have seen series mechanical system in which mass M is in series with spring K and damper B and a force F acts above the mass M. Therefore, the equation for series mechanical system is, we have seen directly, I will write here, F is equal to md square plus bd plus k into x. Similarly, the equation for series electrical system is given by E is equal to LD square plus RD plus 1 upon C into Q. Therefore, again I will write these two equations. F is equal to md square plus bd plus k into x, and E is equal to into bracket LD square plus RD plus 1 upon C into Q. Therefore, by comparing the above two equations, it shows that the differential equation of operation for each system has the same form. The terms which occupy corresponding positions are called analogous quantities. Therefore, this particular analog is referred to as the direct analog. The analogous quantities for a direct analog are shown in table. Now from these two equations, if you will compare md square and ld square, therefore you can say that m is equal to L. If you will compare this BD and RD, you can say that B is equal to R. If you will compare this K and 1 upon C, therefore you can say that K is equal to 1 upon C. F is equal to E and X is equal to Q. Therefore, same things has been written in this table. Analogous quantities in a direct, that is force voltage analog. Force is equivalent to voltage. Velocity x dot, which is equal to dx, is equal to current I is equal to dq. Displacement x is equal to charge q. X is equal to q. F is equal to E. Mass M is equal to inductance L. Mass M is equal to inductance L. Viscous damping coefficient B is equal to resistance R. B is equal to R. And spring constant K is equal to reciprocal of capacitance, that is 1 upon C. Therefore, K is equal to 1 upon C. Therefore, this analog is known as direct analog. Therefore, the total force acting on a group of mechanical elements in series is equal to the sum of the forces exerted on each element. This already we have seen in case of series mechanical element. Similarly, the total voltage drop across a group of electrical elements in series is equal to the sum of the voltage drops across each element. This also we have seen in case of series electric circuit. Thus, in constructing a direct analog, series mechanical elements are replaced by analogous series electrical elements. Therefore, while constructing a direct analog circuit, what we have to do? We have to replace series mechanical elements by series electrical elements and parallel mechanical elements by parallel electrical, analogous parallel electrical elements. Similarly, same thing has been written here for parallel mechanical elements. Already we have seen this theory earlier. For parallel mechanical elements, the force acting on each element is the same, and for parallel electrical elements, the voltage drop across each element is the same. Thus, in a direct analog, parallel mechanical elements should be replaced by equivalent electrical elements in parallel. A direct analog is also called a force voltage analog, in that force and voltage are analogous quantities. Therefore, this is nothing but direct analog. We have to remember this table. This table is very important while constructing direct analog circuit. Now next, inverse analog. The other type of analog is the inverse analog. To construct an inverse analog, first note that the total current flowing through a group of electrical elements in parallel is the sum of the currents in each element. This is analogous to the fact that the total force acting on a group of mechanical elements in series is the sum of the forces acting on each element. Thus, to construct an inverse analog, series mechanical elements must be replaced by parallel electrical elements. Therefore, again, similarly, in an inverse analog, it can be shown that parallel mechanical elements should be replaced by series electrical elements. Thus, the arrangement of series and parallel elements is inverted in constructing an inverse analog. That is, series elements are replaced by parallel elements and vice versa. An inverse analog is also called a force current analog, in that force and current are analogous quantities. Therefore, now we will see an inverse analog circuit. Analogous quantities for an inverse analog may be determined by comparing the equation of operation for the parallel mechanical system with that for the series electrical system. Now we will consider first of all one parallel mechanical system, we will consider series electrical system, and we will correlate or we will find out similarity between these two circuits, parallel mechanical circuit and series electrical circuit, and then we will correlate the terms or elements, and therefore whatever we will obtain, that is known as inverse analog. Therefore this is the parallel mechanical circuit. Already we have seen two springs are there, K1, K2, two dampers are there, B1, B2, they are connected in parallel, K1, K2, B1, B2, they are connected in parallel, and force F, value of force F for all these four elements remains same, but deflection X is different for different elements. Therefore X is equal to here X1, X2, X3, X4, where X1, X2 is the deflection for K1, K2, X3, X4 is the deflection for B1, B2. Therefore the equation for parallel mechanical elements is given by X is equal to F, I have taken common, 1 upon K plus 1 upon BD plus 1 upon MD square. Therefore if you will multiply by capital D here, what will happen? Dx means dx by dt is equal to x dot, which is equal to, into bracket, we have to multiply capital D on both sides. Therefore dx is equal to x dot, which is equal to d upon k plus 1 upon b, because that d and d will get cancelled, plus 1 upon md. D 1d will cancel at the d square, therefore 1 upon md will be there, into f. Therefore what equation we have got? X dot is equal to d upon k plus 1 upon b plus 1 upon md into f. This equation is obtained by multiplying this equation by capital D on both sides, that is towards LHS and towards RHS. Next we have seen this RLC series circuit, in which total voltage drop E is equal to EL plus ER plus EC. EL is equal to inductor, R is equal to resistor, C is equal to capacitor, and I is the current flowing through the circuit. Therefore the equation for series electrical system is given by, directly I will write E is equal to LD square plus RD plus 1 upon C into Q. If you will take D common here, D outside of this equation, what will happen? LD plus R plus 1 upon CD is equal to DQ. DQ means I. DQ means I, current I. Therefore that equation I will write here. E is equal to, into bracket, LD plus R plus 1 upon CD into I. We have taken D common from this equation. Therefore again I will write these two equations. X dot means velocity is equal to d upon k plus 1 upon b plus 1 upon md into f. E is equal to LD plus R plus 1 upon CD into I. Now if we will compare these two equations, we will find out similarity, and that similarity is known as inverse analog. Therefore x dot, velocity is equal to voltage drop E, force F is equal to current I, 1 upon K is equal to L, 1 upon B is equal to R, and 1 upon M is equal to 1 upon C, or M is equal to C. Therefore same thing is there. After comparing the above two equations, the analogous quantities for an inverse analog is given by the following table. Therefore this is the inverse analog quantities, whatever I explained. analogous quantities in an inverse or force current analog. Here force F is analogous to current I, velocity x dot is equal to voltage E, spring constant K is equal to reciprocal of inductance 1 upon L, damping coefficient B is equal to reciprocal of 1 upon resistance, and mass M is equal to capacitance C. Therefore, whatever these analogous quantities are there, these we are going to use while solving or while drawing the electric circuit from mechanical circuit. We have to use both direct and indirect analog, means direct analog and inverse analog based on the problem given. Therefore, now we will see some problems. Consider this mechanical circuit in which three coordinates are there: x, y and ground. X, this at x coordinate force F is acting, spring K and damper B is connected in between x and y coordinate, and mass M is connected to y coordinate and ground. Therefore, what is our question? For the mechanical system shown in figure, determine the differential equation relating F and X, construct direct into bracket force voltage analog, construct the inverse, that is force current analog. Therefore, solution. First of all, we will determine or we will draw grounded chair representation of this diagram. Now, what is first step in the grounded chair representation? We have to draw the coordinates and we have to indicate the force acting at the top of that coordinate. Therefore, how many coordinates are there? X, y and ground. Therefore, we have to draw three lines. X, first line will indicate x coordinate, second line will indicate y coordinate, third line will indicate ground, and force F is acting at x coordinate. Therefore, this second diagram. Now, for drawing second diagram, what we have to do? We have to now insert the elements at their respective positions. Which are the elements? K, B and M. These are the elements. Now you just see spring K and damper B is in between X and Y. Therefore, we have to draw here spring K and damper B. Therefore, same is here. Spring K we have drawn and damper B we have drawn in between X and Y. Now at Y coordinate, mass M is there and it is grounded. Therefore, we will draw here mass M like this. Same figure is here. We have drawn mass M connecting to the Y coordinate and it is grounded. Force F is acting at the top. Therefore, we will determine relation now between F and X. Therefore, what we will see, first of all, we will consider these two elements, spring K and damper B. Spring K and damper B are in series. Therefore, their impedance Z1 is equal to what? BD plus K. Z1 is equal to BD plus K. This is the impedance of K and P. Next, the impedance of mass M is Z2. The impedance of mass M is Z2. Therefore, Z2 is equal to MD square. Z2 is equal to MD square. Now, these two impedances Z1 and Z2 will be in parallel. Just see, Z1 and Z2 will be in parallel. Therefore, their equivalent impedance Z is given by Z1 and Z2 are in parallel. Therefore, the total impedance Z is given by, since Z1 and Z2 are in parallel, therefore Z is equal to 1 divided by 1 upon Z1 plus 1 upon Z2. Therefore, Z is equal to, substituting the values of Z1 and Z2, Z is equal to 1 divided by 1 upon BD plus K plus 1 upon MD square. Therefore, we will write the equation F is equal to Zx. Therefore, force equation with respect to X is given by F is equal to Zx. Therefore substituting value of Z, F is equal to into bracket 1 divided by 1 upon Vd plus K plus 1 upon Md square into X. Therefore now we will construct direct analog circuit. Now in direct analog, mass is equal to inductor. This spring constant K is equal to 1 upon C, that is capacitor, and this damping coefficient B is equal to or is similar to or is equivalent to resistance R. Therefore from grounded chair representation, what we have to do? Replace series mechanical elements by series electrical elements and replace parallel mechanical elements by parallel electrical elements. Therefore once again we will draw that grounded chair representation. Now here K and B are in series and M is in parallel with respect to K and B. Therefore what we will do? We will replace these two series elements, two series mechanical elements by two series electrical elements. Therefore since K and B are in series, therefore they are replaced by equivalent series electrical elements, that is capacitance C and resistance R, because K is equal to C and B is equal to R. Similarly mass M is in parallel with K and B, therefore it is replaced by equivalent electrical element in parallel by inductor L, because mass M is equal to inductor L. Therefore we are getting the circuit as direct analog circuit as electrical circuit as like this. See there, K and B are in series. What is K is equal to C, therefore we have drawn first of all capacitor C. What is B is equal to resistance R. K and B are in series, therefore C and R we have to draw in series like this. Now M is in parallel with K and B, therefore what is M is equal to L, therefore you have to draw inductor L in parallel with C and R there, and this E is the total voltage drop. F is equal to E. Therefore this completes our direct analog electric circuit. Now we will construct circuit of inverse analog. Therefore again same diagram is there, that is grounded chair representation. Spring K and damper B are in series and mass M is in parallel with K and B. Force F is acting at the top. Therefore for inverse analog, since K and B are in series, now inverse analog what we have to do? We have to replace series mechanical element by parallel electrical element. Therefore since K and B are in series, therefore they are replaced by equivalent parallel electrical elements, that is K is equal to L and B is equal to resistance R. Similarly mass M is in parallel with K and B, therefore it is replaced by equivalent electrical element in series by capacitance C, because in inverse analog M is equal to C. M is in parallel, therefore we have to replace it by series electrical element. Therefore equivalent diagram is, see that this is the equivalent diagram. Since K and B are here in series, of these two elements we have to replace by two equivalent electrical elements in parallel. Therefore K is equal to L and B is equal to R. Therefore these we have to place in parallel like this. And here M is in parallel with K and B, therefore M we have to replace by capacitance C. But in case of inverse analog, parallel combination should be replaced by series combination. Therefore here we will add capacitor C with series to this inductor L and resistance R, and this force is equal to voltage. Therefore this circuit is known as inverse analog electrical circuit. Now next problem, example 2. For the mechanical system shown in figure, first construct the grounded chair representation. Second, obtain the overall equation relating f and x. Third, C. Construct the electric circuit which is the direct analog. Therefore, this is our diagram. Spring K1 is there, it is connected to the x coordinate and to the ground here. At x coordinate, force F is acting. Spring K2 and damper B2 is in between x and y coordinate, and at y coordinate mass M is there. Therefore, we will determine first of all its grounded chair representation. Therefore, solution, the grounded chair representation is, therefore we are knowing what is the first step. Draw the coordinates. How many coordinates are there in the figure? In this figure, x, y and ground. 3 coordinates are there. Therefore, we have to draw 3 lines and we have to indicate the force F at x coordinate. Therefore, this is the first step. Draw first horizontal line, indicate x coordinate. Draw second horizontal line, indicate y coordinate. Draw third horizontal line, indicate it as ground, and show force F at x coordinate, because here in this original diagram force F is at coordinate x. Therefore, now we will insert the element at their respective positions. Now we just say K2 and B2 are in between x and y coordinate. Therefore, here we will insert K2 and here we will insert B2. And K1 is in contact with x coordinate and ground. Therefore, K1 will indicate here x coordinate and with respect to ground. Therefore, see that this diagram is there. K1 is connected to the x coordinate and ground. Therefore, we have drawn K1 x coordinate to the ground, and this is y coordinate, this is ground line. Force F is acting is at x coordinate. Now next step, K2 and B are in between x and y coordinate. Therefore, we have drawn K2 and B in between x and y coordinate. Similarly, we have to draw mass M at y coordinate and we have to show it as grounded. Therefore, next step, K1 is as it is, K2 is as it is, B is as it is, just we have drawn M at y coordinate. Therefore, this completes our grounded chair representation. Now we will find out relation between F and X, and we will construct at last direct analog electric circuit. Now, therefore, this is our grounded chair representation. The impedance of K1 is Z1 is equal to K1. Similarly, K2 and B are in series. Therefore, their impedance Z2 is equal to BD plus K2. Again, same diagram is there. The impedance of M is Z3 is equal to MD square. Therefore, now that Z2 and Z3 they will be in series, because this K2 and B are in, they are replaced by Z2 and M we have replaced by Z3. Therefore, 3 springs are there, Z1, Z2, Z3. Now Z2 and Z3 are in parallel. Z2 and Z3 are in parallel. Therefore, their impedance Z4 is given by Z4 is equal to 1 divided by 1 upon Z2 plus 1 upon Z3. Therefore, substituting values of Z2 and Z3, Z4 is equal to 1 divided by 1 upon BD plus K2 plus 1 upon MD square. Now this Z4, Z2 and Z3 is replaced by Z4. Therefore, we will get 2 springs, Z1 and Z4 in next slide. See here, Z1 and Z4. Now Z1 and Z4 are in series. Z1 and Z4 are in series. Therefore, their impedance Z is equal to Z1 plus Z4. Therefore, Z1 is equal to K1 plus, we have to substitute value of Z4, that is 1 divided by 1 upon Bd plus K2 plus 1 divided by Md square. Therefore, the equation between F and X is F is equal to Zx. Therefore, substituting value of Z, F is equal to K1 plus 1 divided by 1 upon Bd plus K2 plus 1 upon Md square into X. Therefore, this is equation relating to F and X. Now, we will construct direct analog circuit. Again, same grounded chair representation is there, K1, K2, B and M. Now, you just see K2 and B are in series. Therefore, here two electrical elements in series will be there. And this K2 and B are in parallel with M. Therefore, this M we have to replace by the capacitance, and that capacitance will be in parallel with this two electrical elements. And at last we have to show this series electrical one element in series replaced by K1. Therefore, now in direct analog, M is equal to L, K is equal to 1 upon C and B is equal to R. Therefore, analogous electrical system for given mechanical system with the help of grounded chair representation is. Now what we have to do? Instead of K, we have to show capacitance C, the capacitance C1. Instead of spring K2, we have to show capacitance C2. Instead of damper B, we have to show resistance R, and instead of mass M, we have to show inductor L. Now see that how the circuit is there. Therefore, as spring K1 is in series with the combination of spring K2 and damper B and mass M. Therefore, once again, what is the rule? All series mechanical elements are replaced by series electrical elements and parallel mechanical elements by parallel electrical elements. Therefore, once again I will draw the diagram. Now, previous slide we have seen which are the equivalent elements. Therefore, we will construct the electric circuit, direct analog electric circuit. Therefore, this is our direct analog electric circuit. Now, K1 is equal to C1. Now, K2 and B are in series. Therefore, K2 is replaced by C2 and B is equal to R. Therefore, C2 and R are in series. Now, M is replaced by L, but M is in parallel with K2 and B. Therefore, this inductor L we have to construct in parallel with C2 and R. And with these three elements, this K1 is equal to C1. K1 is in series with these three elements. Therefore, this we have to indicate C1 in series with this all the three elements. And here it is F, and here it is voltage drop E. Therefore, this circuit is nothing but direct analog electric circuit. Now, we will see last problem. For the mechanical system shown in figure, construct the grounded chair representation. Obtain the overall equation relating F and X. Construct the electric circuit which is the direct analog. Therefore, this is our diagram. Force F is acting at coordinate X. At coordinate X, mass M is there. Spring K1 is in between X and Y. Spring K2 and damper B2 is connected to the Y coordinate at one end, and at the other end it is connected to the ground. Therefore, solution. the grounded chair representation is. Therefore, what is the first step? We have to check how many coordinates are there. Three coordinates are there, x, y and ground. Therefore, draw the three lines x, y and ground, and force F is acting at x coordinate. Therefore, show force F acting at x coordinate. Now we will insert one element one by one in these coordinates. Therefore, first step is again next, mass m. Mass m is connected to the x coordinate and it is grounded here also. Therefore, mass m you have to connect to the x coordinate and you have to show grounded. This is y coordinate will remain as it is and this is ground. Now again same figure. Now this spring K1 is in between x and y coordinate. Therefore, I have drawn spring K1 in between x and y coordinate. Now B2 and K2, one end is connected to y coordinate and other end is to the ground. Therefore, construct here B2 and K2. K2 connecting one end to the y coordinate, other end to the ground. B2 connecting one end to the y coordinate and other end to the ground. Therefore, this is nothing but our grounded chair representation of this diagram. Therefore, again same diagram is there, mass m, spring K1, spring K2, damper B2, x, y, ground, force F is acting. Therefore, the impedance of mass m is Z1 is equal to md square. Similarly, for this K1, the impedance of K1 is Z2 is equal to K1. Now again same diagram is there. K2 and V2 are in series. K2 and V2 are in series. Therefore, their impedance Z3 is equal to B2D plus K2. Z3 is equal to B2D plus K2. Therefore, we will replace this diagram by three impedances, that is Z1, Z2 and Z3. Therefore, this is the diagram Z1, Z2, Z3 F. Now Z2 and Z3 are in parallel. Therefore, their impedance Z4 is equal to 1 divided by 1 upon Z2 plus 1 upon Z3. Therefore, substituting the values, Z4 is equal to 1 divided by 1 upon K1 plus 1 upon B2D plus K2. Now, this Z2 and Z3 is replaced by another spring, that is Z4. Therefore, next diagram, Z1, Z4. Therefore, Z1 and Z4 are in series. Therefore, their impedance Z is equal to Z1 plus Z4. Substituting the values of Z1 and Z4, we get Z is equal to M1D square plus 1 divided by 1 upon K1 plus 1 upon B2D plus K2. Therefore, the equation between F and X is F is equal to Zx. Therefore, substituting the value of Z, F is equal to M1D square plus 1 divided by 1 upon K1 plus 1 upon B2D plus K2 into X. Therefore, this is our relation between F and X. Now, we will construct direct analog circuit. Now, for direct analog, M is equal to L, K is equal to 1 upon C and B is equal to R. Therefore, replace series mechanical elements by series electrical elements and vice versa, that is parallel mechanical elements by parallel electrical elements. Therefore, again I will draw this grounded chair representation. Now, M is equal to L, you have to draw M is equal to L. This K1 is equal to C1, K2 is equal to C2 and B2 is equal to R2. Now, you just see how the diagram is there. For the mass M, we have to indicate inductor L. See that for the mass M we have drawn inductor L. Then this for this K1 we have drawn this capacitor C1. Now this K1 is in parallel with K2 and V2. Therefore this C1 should be in parallel. Therefore draw this parallel circuit. K2 is equal to C2 and then B2 is equal to R2. Then F is equal to E. Therefore this completes our this direct analog circuit. See that mass M is equal to L. Mass M is in series with all these three elements. Therefore this inductor L should be in series with these three elements. It is in series. K1 is replaced by C1. K1, this K2 and V2 are in series. Therefore K2 is equal to C2 and R2. V2 is equal to R2. They should be shown in series. C2 and R2 should be shown in series. And this C1 should be in parallel with C2 and R2 because K1 is in parallel with K2 and V2. Therefore draw C1 in parallel with C2 and R2. Therefore this is the end of the analogies. Thank you very much.